next unit that we're going to start is our thermochemistry unit or our energy unit. So the first thing we're going to talk about is specific heat. So the amount of heat energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So basically what specific heat is telling us, and each substance has its own specific heat, it's telling us how much energy that we need to put into that substance in order to get 1 gram of that substance to increase its temperature by only 1 degree. And when we're talking about degrees here, we're talking about degrees Celsius or Kelvin. In science, we are not talking about Fahrenheit at all. Okay, so the amount of heat transfer depends on the substance, like I just said, because the specific heat is particular for a substance, the mass of the substance, and the size of the temperature change. Later on, we're going to talk about the difference between heat and temperature, but for now, for this equation, you just have to realize that there is a difference between those two. Okay, so here's the specific heat equation. Let me explain what all these letters mean. All right, so we have Q is equal to mCp times delta T. So Q here is going to be our heat. Heat is a type of energy. So it's the amount of heat that is absorbed or released. So previously we've talked about exothermic and endothermic. Here we're talking about the amount of heat absorbed or released. So if heat is absorbed, that's going to be an endothermic. If heat is released, that's going to be exothermic. The units that we're going to be talking about for heat and for any type of energy is joules. And we can write that as a capital J. Okay, so that's going to equal to M, which is mass, so grams, like what we've been dealing with in the past. Then we have Cp. Our Cp stands for specific heat, and that's the amount of heat required to raise 1 gram 1 degree Celsius, or 1 degree Kelvin. So that's Cp. P stands for constant pressure. So whenever we're doing specific heat, we're assuming that the pressure is not changing at all. The units that we're going to be using for this are joules divided by grams times degrees Celsius, or joules divided by grams times Kelvin. This last part right here is change in temperature. So this right here, this is what we call a delta. Delta means change in. So when we're thinking about delta, we're going to be thinking about the final temperature minus the initial temperature. And again, when we're talking about temperature, it's going to be in either Kelvin or degrees Celsius. Okay, so let's just do a few of these problems. Determine the energy of a 35-gram sample with a specific heat of 0.069 joules per gram Kelvin that was heated from 293 Kelvin to 313 Kelvin. First thing we're going to do here is write out our equation. So we have Q is equal to mc delta T. The way that I remember this equation is Q is equal to mcat. So Q is equal to M, kind of forget that P is there, C, the triangle kind of looks like an A, and then T. So Q is equal to mcat, if that just helps you remember it quickly. All right, so here we're trying to find the energy, so that's going to be our Q. So we have Q is equal to mass, so they gave us 35 grams. Then they told us that the specific heat was 0.069, so we're going to multiply that. And then change in temperature. So we're doing change in temperature, doing final minus initial. So it's going to be 313 minus 293 Kelvin. Now here we're just going to have to plug this all into our calculator. Make sure you do your subtraction first, or you put it into parentheses so that your numbers come out right. Okay, the answer that I got here was 48.3, and then our units, if you look, our grams are going to cancel out with our grams, our Kelvin is going to cancel out with our Kelvin, so we're going to be left in joules. Make sure we look at our significant figures though. So here we only have 2, here we have 2, and here we have 3. So we're going to have to use our least amount. So Q is going to equal 48 joules. Okay. A piece of copper alloy with a mass of 85 grams is heated from 30 degrees Celsius to 45 degrees Celsius. It absorbs 523 joules of heat. What is the specific heat? Okay, so we're going to be starting with our Q is equal to mCp delta T. And this time we're solving for specific heat. So that's going to be our Cp. In order to get Cp by itself, we're going to have to divide through by our mass and delta T. So we're going to have Q divided by m delta T is equal to Cp. Now we're just going to plug in the numbers that we have. So our Q absorbs 523 joules, so that's going to be our Q, divided by our mass, which is 85 grams, times the change in temperature. So 45 minus 30 is going to be 15 degrees Celsius. So now we just divide that. And we get 0.41. We have, so when we do the subtraction, we're going to end up with 2 sig figs. We have 2 here, 3 here, so we're going to need 2 sig figs, and then our units. So our units here are going to be joules divided by grams times degrees Celsius. This is our last problem. Heat in the amount of 420 joules is added to 35 gram sample of water at a temp of 10 degrees Celsius. What is the final temperature of the water? So here I'm telling you that the specific heat of water is 4.18 joules divided by grams Kelvin. So we're trying to figure out the final temperature. So once again, we're going to start with our equation. But here we just want to know our final temperature. So we need to keep in mind that this equation really reads T final minus T initial. What we're solving for here is T final, so we're going to have to rearrange this equation. So we can divide through by mass and specific heat. So Q divided by mass specific heat, and that leaves us with T final minus T initial. In order to get T final to T initial to the other side, so you just have T final left over, we have to add it to the other side. So we're going to end up with Q over M times Cp plus T initial is going to give us T final. Now we're just going to plug in. So I'm going to do that over here. So Q is 420 joules over our mass, which is 35, times our specific heat, and then we have to add our initial temperature. If you notice though, our initial temperature is given to us in degrees Celsius, but our specific heat is in Kelvin. The way that we're going to go back and forth between degrees Celsius and Kelvin, Kelvin is equal to degrees Celsius plus 273. So if we add 273 to 10, we are going to get 283. we're going to get an answer of 286. And here we're looking for final temperature, so it's Kelvin. This one's a little bit more tricky. We're going to do more problems like this in class, but I just wanted to introduce it to you.